Hello, my name is Davor Barić, and today I will talk about testing environment for ADAS software solutions. The last decade has been marked by the remarkable progress and development of autonomous driving. Most of the changes the autonomous vehicles bring to the existing transportation system are favorable and advanced. Some of the positive changes are the reduction of human errors and traffic jams, greater driving comfort and productivity, greater mobility of users and products, and better shared transport. In this paper, one such testing environment for ADAS solution is analyzed. The environment is implemented in Python programming language. Several shortcomings were identified, such as storing tests in one large dictionary and using the same dictionary throughout the system, which can be described as impractical. Also, the existing solution can store dictionary RAM, which leads to the problem of data loss in case of incorrect shutdown of the system. Suggested improvements include the use of a SQLite database that allows for increased robustness and security of the entire system, while the test processing timing comparable to the processing time of the existing environment. ADAS is a term used to describe the growing number of active and passive safety features in vehicles. The aim of such systems is to improve the safety of drivers, passengers, and pedestrians by reducing the total number of traffic accidents and the seriousness of the consequence of motor vehicle accidents. The purpose of testing is not only to verify that the program is working properly, but check the security, reliability, or evaluate the performance of the final solution. With the ADAS system, it is possible to test at a complete vehicle level and at a functional level. The difference is that only a single ADAS function is tested and verified at the functional level, while at the complete vehicle level, the interaction between the ADAS function and the rest of the vehicle is checked. This paper deals with the functional testing. Today, engineers are increasingly using the Python programming language due to its ease to learning, efficiency and portability across different operating systems. Python was chosen to realize improvements to the existing solution because of the ability to run on different operating systems and because the existing test environments was already implemented in the Python programming language. This makes the integration of modifications into existing test environment much easier. SQLite is the most used database engine today. Such a database is fast, self-contained, and has high dependability. In addition, the SQLite database is free and can be easily used and created, and is therefore used in graduate work. Some benefits of SQLite database are no additional program or components required to run. Database sharing is very easy, and SQLite is based on the standard SQL language. The existing testing solution is a tool used to find, prepare, and run automated test cases. For each test case, it is necessary to have a prepared test header that contains all the necessary information about each test so that it can be performed. Each test file consists of the functions required for the test to function properly, and test header in the form of a dictionary containing test data. The information is specific to each test. The length of the header and the names and values of each keyword are specific to each test. Insights into the existing solution have noted shortcomings such as storing tests in one large dictionary and using the same dictionary throughout the environment, which can be described as impractical, unsafe, and imprecise. In order to achieve certain improvements, it is necessary to use a database that is a much more robust, stable, secure, and transparent data storage solution than than the existing one. Improvements to the existing testing environment for ADAS software solutions can be presented by the following requirements. Finding all files, testing folders and subfolders, accelerate program execution by reading only part of the file containing test data, saving individual test data to the database, detecting changes to each test and modifying the database and retrieving data about each test from database and handling them, and greater or least equal speed of execution in comparison with the existing solution. One table provides general test data, while the other contains header values. Each key in the dictionary that contains test headers would represent a column in the table, while the corresponding key value will represent a row in the table in database. It was decided that the ability to recognize changes in each test would be beneficial, since tests are often changed, so it is necessary to update the already saved test. Now, a figure shows the flowchart of the proposed solution. For the purpose of comparison of it was first necessary to perform measurement on an existing environment. That has a way of storing tests in one large dictionary. Table 1 shows the measurement of adding test time to an existing environment. From the presented results, it is evident that with the increase in the number of tests, the time of addition to the dictionary is approximately linearly increased. Before integrating the proposed solution in the existing environment, the evaluation was performed on tests such as those used in the existing environment. The test proved the correctness of adding a test to the database. The next check involved inspection that each test was correctly added to database. Testing has confirmed that the header is correctly written to the database. The result of the first version of the standalone solution implemented on computer C1 are shown in table. As it can be seen, there are 2 times reported in the table. The first addition time represents the time it takes for tests to be added when the database is completely empty, and the second time in the table represents the time it takes to add tests in case we already have a complete database and it is necessary to go through the entire table and make changes if necessary. The obtained results shows the proposed solution has significantly higher times of test addition in database in comparison with existing solution. The way to reduce the time of test adding was to combine 2 optimizations in the database settings. First, Pragma asynchronous is off, and Pragma general mode is memory. First table shows the results of the standalone solutions after adding a combination of 2 optimizations to the database. It can be seen from first table that the optimized version of the standalone solution shows good results, both on a small set of tests and on a large one. As the result seemed promising after adding the aforementioned combination of optimizations, integration of the proposed solution within the existing environment was performed. The integrated solution in the existing environment was tested on computer C2, and the obtained results are shown in table 2. The very first results after successful integration into the existing environment gave worse results on a small set of tests. compared to the optimized version of the standalone solution. By comparing the existing environment and the integrated solution, significant jumps in processing time can be seen after 100 tests with the integrated version, while the time to add test to the database was reduced by the optimized version of the standalone solution. That is, it was significantly faster than the first standalone version. There was an important slowdown during integration in the existing environment. Some of the reasons may also be a constant check that the database exists and constant connection to it, and poor code optimization during integration and the like. However, the proposed solution uses a database that is a much more robust, stable, and secure data storage solution than a dictionary. This paper deals with the improvement of the existing environment for testing ADAS software solutions. The goal was to improve the current way of storing tests, which was performed on the existing environment by storing the test in one large dictionary. Such a method is quite impractical and unstable. Therefore, a new way of data sharing is proposed, which involves usage of SQLite database. Part of the task related to the use of the SQLite database has been successfully completed by storing the tests that were previously stored in one large dictionary into the SQLite database. As a future improvement of this code, it is necessary to compare the code more closely with the optimized version of the standalone solution. Careful analysis of the program code should make it possible to identify the parts that contributed to a significant slowdown in the integrated version of the proposed solution. The answer to the first question is the Hill environment also used the test environment described in this paper. And the answer to the second question is, I think you can get some extra optimization in the program code. Thank you for your attention.